Hello everyone, I am Nikita Nayak from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In previous video lecture, we learned about random variables and probability distribution, and today we are going to learn about probability function. So first of all, probability distribution function or probability mass function. So probability distribution functions or probability mass functions, that is PMF or PDF, are those functions which give us probability corresponding to discrete random variable. Thus, if x is a discrete random variable, then probability of x is equal to f of x. Now, the characteristics of a probability mass function are: first, f of x greater than equal to 0 for all x. That means for all x, the value of the function is either 0 or greater than 0. Here also we can write probability of x is greater than or equal to 0, because probability of x is equal to f of x. Second, summation over x, f of x is equal to 1. That means sum of all probabilities is equal to 1. Here we can also write summation over x, p of x is equal to 1. Number 3, probability of x is equal to xi or xj is equal to probability of x is equal to xi plus probability of x is equal to xj. So, the probability mass function is only defined for discrete random variables. Now, second, probability density function or frequency function. The probability function of a continuous random variable is called probability density function or frequency function. Thus, if x is a continuous random variable, then probability of x is equal to f of x. Now, the characteristics of a probability density function are: first, f of x greater than or equal to 0 for all x. That means function is always non-negative. And number 2, integration minus infinity to infinity f of x dx is equal to 1. So, probability density function or frequency function is only defined for continuous random variable. Now, third, distribution function or cumulative distribution function. We know that probability mass function is only defined for discrete random variable and probability density function is only defined for continuous random variable. But distribution function is defined for discrete random variable as well as continuous random variable. Now, for discrete random variable, the probability f of x is equal to probability of x less or equal to x is equal to summation capital X over small x f of x is called the cumulative distribution function or simply a distribution function of the discrete random variable. That means cumulative distribution function or distribution function is denoted by capital F of x and defined as probability of x less or equal to x is equal to summation over capital X less or equal to small x f of x. Now, for discrete random variable, we have given x equal to 0, 1 and 2 and probabilities are given 1 by 4, 2 by 4 and 1 by 4. Now, we have to find the distribution function for these probabilities by taking cumulative sum of probabilities. So here capital F of x is equal to 1 by 4. Here 1 by 4 plus 2 by 4 is equal to 3 by 4. Now here 1 by 4 plus 2 by 4 plus 1 by 4 is equal to 4 by 4. So distribution functions are 1 by 4, 3 by 4 and 4 by 4. Now for continuous random variable, the probability capital F of x is equal to probability of x less than or equal to x is equal to integration over minus infinity to x f of x dx is called the cumulative distribution function or simply a distribution function of the continuous random variable. Now we have given example for f of x is equal to 1 if 0 less than x less than 2 and f of x is equal to 0 elsewhere. So here we have to find the distribution function for this function. So first of all, for x is equal to 0, here we know that distribution function is equal to integration over minus infinity to x f of x dx. Here we have to find for x equal to 0. So f of 0 is equal to integration from minus infinity to 0 f of x dx. In minus infinity to 0, that is the value less than 0, we have given function equal to 0. So integration minus infinity to 0 0 dx and integration of 0 is 0. So f of 0 we get 0. Now for x is equal to 2, we know that f of x is equal to integration from minus infinity to x f of x dx. Now x is equal to 2. So we have f of 2 is equal to integration from minus infinity to 2 f of x dx. Here we have total two values of function, one in 0 to 2 and either it is 0, and here we have interval minus infinity to 2. So first of all we have to separate the interval. So we separate the interval as minus infinity to 0 and 0 to 2. So in next step we have integration from minus infinity to 0 f of x dx plus integration from 0 to 2 f of x dx. In minus infinity to 0 we have function is 0. So we have integration minus infinity to 0 0 dx plus integration 0 to 2. In 0 to 2 we have function is 1. So we have integration 0 to 2 1 dx. Integration of 0 is 0. Here we have integration 1 into dx. So it is integration of dx and we know that integration of dx is equal to x. So here we get x. Or we know that integration x raised to n dx is equal to x raised to n plus 1 over n plus 1 where n is not equal to minus 1. So here we have 1 that is x raised to 0. So integration of x raised to 0 dx is equal to, now comparing with this equation we have n is equal to 0. So here we get x raised to 0 plus 1 over 0 plus 1 is equal to x raised to 1 by 1, that is x. So here we get x. Now substituting the limit, upper limit minus lower limit. Here 2 is upper limit and 0 is lower limit. So upper limit minus lower limit we get 2 minus 0 and 2 minus 0 is equal to 2. So we have f of 2 is equal to 2. So here for x is equal to small x we have f of x. For x equal to 0 we have f of 0 is equal to 0, and for x is equal to 2 we have f of 2 is equal to 2. So for x equal to 0 distribution function is 0 and for x is equal to 2 distribution function is 2. In next video lecture we will learn about properties of random variable and examples. Thank you.